Wait. Let me call him back again. Hello. Abdul, can you please check now? Right. So what is your name actually in the on the login name? SATHAR. I can see two Satar. Is it a capital or small letter S? Small S, okay. I'm admitting you. Just give me a second. Are you in now? All right. Just give me a second. Hi, Vinesh. Mr. Abdul Sattar joined actually. Karthik. So can you
Yeah.
please make him host?
Wait.
Right. So, Mr. Abdul, will you be sharing the screen or how? Or you'll be sharing from here? All right. So initially, Mr. Karthik will be giving an introduction. He will welcome you and he will just give a brief introduction. Then after that, you can start. All right. So we are just going to live on YouTube also. All right. Thank you, Mr. Abdul. Sorry, Vinesh, is it all good?
Yeah, he's co-host right now.
Right.
Shri,
Karthik, hello, Karthik.
Yes,
You are ready right now?
yes, I'm ready. Tell me when you're letting them in.
okay, Shri is also in the meeting.
Hi, we have the speaker here, right? Abdul sir.
Yes.
Okay. Welcome, sir, to CSR Box session over here.
Thank you.
So I'm letting in the students. Okay.
Yes. Hello, everyone. Welcome to the mentoring session of the IBM Skills Build Summer Certification Program 2025. Today, we have a great session ahead of you, and we are very happy to have Mr. Abdul Sattar with us today. He is a senior data scientist at IBM and works at some of the latest and most exciting technologies. In this session, he'll talk to us about RAG, what it is, how it has grown, and where it is used. Get ready to learn from an expert and explore the world of tech together. So, welcome, Mr. Abdul. Please take us through the journey of how RAG has evolved. What are its applications? Please.
Thanks, Karthik, for the warm welcome, and I welcome all the students and those who are participating in this certification. So, welcome all. The goal of this session is to give you an insight on RAG. We'll talk about what RAG is, but just to set the tone for this session, my only requirement from you is that this would be both a theoretical as well as a practical demo-based experience that you would go through. But I would like to keep this as interactive as possible. So feel free to post your questions in the chat, or stop me wherever you feel that things are not understandable. And ideally, post it in the chat so that we are able to address all the questions at the end. And we'll begin with the presentation first to get some background information, and then we can talk about the demo part as well. Right, I'll start sharing my screen in a second. Give me 1 second, it is asking for permission. All right, are you able to see my screen? Can somebody give a thumbs up?
Yes, sir. Your screen is visible.
Yes, we are able.
All right, let me put this in screen share mode and we get started. There are too many boxes out here, so let me move those out. Okay. All right. So before we start, a quick intro about myself. As Karthik mentioned, I work at IBM currently. But before that, I have experience of working with General Electric and also Kyndryl. I've been in the data science domain for the past decade, where I've worked with various data science technologies. I'm a master's in business administration, and you might wonder, somebody from an MBA background doing the data science work. I think that's what destiny had for me. So I did my MBA in finance, but then in 2015, I realized that my love for numbers and analysis. So that's when I shifted my career from reporting analysis onto the data science work. We've done some excellent projects at IBM, and one of them was also nominated for Stevie Gold Award, and we won that back in 2019. So what I do at IBM, I think it's all about in and out data science work. So transforming unstructured data into business intelligence so that the executives can make decisions. Translate the cutting edge research in terms of, everybody knows how quickly the tech domain is changing. So it's really important for us to keep up with all the changes that are coming up and apply those in our real world scenarios. And then one of the key things that I like the most is mentoring budding data scientists, because I think that's one way of giving back to the community based on whatever I have learned so far. Right, so without wasting much time on my details, let's jump into the RAG part. So how many of us are already aware of what RAG is? Apart from just the definition, how many of us are already aware of what RAG is? Just give me a thumbs up, thumbs down. Guys, need you to be active so that we make this an interactive session. Right, RAG stands for Retrieval Augmented Generation. I do understand that there have been a few masterclasses that have gone in for you already. That was about some of the AI technologies. In today's session, we will be covering a RAG-based approach. Karthik, I need some help in terms of taking out this particular section so that, how do I hide this one? Because, okay, great. Now, for the agenda for this particular session is we'll explore what RAG is. We'll understand in plain terminology as to what RAG is, and then we talk about the evolution of RAG and how it operates currently and what are the applications that are based off of RAG. And then we'll have a quick demo that based on the project that we've developed at IBM that can help especially the newcomers to implement RAG and play around with the functionality of RAG. As I mentioned, RAG stands for Retrieval Augmented Generation. And it is one of the most common useful applications. And again, I don't want to give you the textbook information, but RAG, as you can assume this as, so if I were to give you an analogy, assume that you are sitting in KBC, Kaun Banega Crorepati hot seat, right? And you get the one question for 1 crore, all right? You know the answer for that particular question, but you're not 100% confident, all right? So then you have the option of calling your friend and checking what the answer is. You can also tell your friend that, this is what you think, and also get a confirmation from your friend to say that, is this the right answer, or is he confident about that part? Okay, so that's the augmentation part. So we all know that LLMs are good at generating text or generating information on the fly, right? But there's also a challenge where LLMs can give responses which are not 100% accurate, but they think that they are 100% accurate and give it to that user. And using that information may cause, unforeseen consequences. So what we do is we provide that context to the LLM that says that, okay, this is the question. And based on this, the documents that I have says this. Now, based on these two things, you generate some information that is more accurate than what could be when you generate it on your own. Okay, so as it says here, it combines information retrieval, which is like, getting the information from a particular source. And on top of that, using that as the context, it will generate information that is more accurate, which may not be the case when it is generating information on its own without taking the context into account, right? So let's move to the next slide. So before we talk about RAG, we need to understand the functionality of large language models. Large language models are designed based on transformer architecture, right? And again, those who do not know what is transformer, it's a neural network based architecture that works on encoder and decoder functionality. But without getting into too much of technicalities, the function of large language models is that it is trained on massive amounts of data, sometimes, almost the data that's available on the internet. And based on that, it would acquire some knowledge. And that knowledge is stored in the form of parameters. We hear that, ChatGPT or Llama is trained on 70 billion parameters. Parameters is nothing but those knowledge points that it will create by going through massive amounts of information, right? And the higher the amount of parameters that the LLM has, the more confident and the more responsive is the LLM in terms of answering all the questions that are available. And users generally access this information or this knowledge by passing in a question, which is also known as prompt in the LLM terminology. Now, we all agree that LLMs were working fine. So when ChatGPT came out, and then we also had, the Geminis, the Perplexity, all of these things keep coming out, right? But you may have realized that, and you may also have seen some memes on internet that said, I asked, is 4 plus 5 greater than 10? It said the answer is no, but then somebody cross-questioned it and said, no, 4 plus 5 is greater than 10. And then it hallucinated and gave the response, okay, if you're saying so, then it might be the right answer. Whereas we as humans are able to comprehend that information and say that, irrespective of whether you say yes or irrespective of whether you say no, 4 plus 5 is equals to 9, and 9 is always less than 10, right? That is a confidence that we as humans have gained based on the interactions that we've had with our other human beings or with the books that we've read, all of that information. But LLM has its own limitations, right? And the purpose we have to learn RAG is because to address those limitations that we have with RAG, we bring with LLM, we bring in the concept called RAG. So let's look at the three major drawbacks that LLMs have that required us to come up with the RAG approach. So the first one is limited knowledge on private data. So how many of you remember that when ChatGPT came out, it had a cutoff that said that, it was trained on X amount of data, and any information apart from that particular data set, it would not have an answer for that. It would just simply say that, this is not something that I've been trained on. I would not be able to answer this question. So LLMs have that drawback where their knowledge is limited, especially on private data. What does private data mean here? Private data means that data that is not readily available on the internet. So for example, if a company has a leave policy, right? They may not have that leave policy available on the internet for everyone to see. It would be available on the company's own website or the internal website, where only the employees would have access to that data. Similarly, for banks, the locker information, or let's say what are the transactions that are happening, all of that information is not going to be readily available on the internet. So that data is known as private data. So now if I go in and type on ChatGPT asking, can you explain to me what is the leave policy at IBM? The simple response would be, it would give you a generic response that says in general, the leave policy means XYZ thing, all of that. But it would never be able to clearly tell you that at IBM, you get X number of holidays and you have X number of general holidays that are available, and you can avail, so many sick leaves in a year. All of that information would not be available. That information is known as private data. So not all LLMs are trained on private data, and it would require us to bring the LLM and pass in our private data to the LLM and then train it so that we would be able to interact with the LLMs with the information that we have. That's number one. Number two, the knowledge cutoff date. Okay, so let's say we have a cricket match that's going on today, as of today, India versus England, right? If you go in and type a question, who are all part of the team as for today's test match? None of the LLMs would have that information because they have been at most been trained as of yesterday, but not today, right? So that knowledge cutoff, getting information on the fly, is not something inbuilt in the large language models. They would always have that cutoff, and any information that gets generated after that cutoff date, the LLMs would not have information pertaining to that. Because of that, there is that limitation that you are not guaranteed that you get 100% accurate information for the questions that you ask all the time. And the last, but the most important, is hallucinations. Hallucination was more of a medical term that's now being applied to LLMs. Hallucination generally means that assuming some things are happening, whereas in reality, those are not happening. All right. So how does that apply to LLM? LLM, when you ask a question to LLM, based on the parameters that it has been trained on, it will try to fetch some information from the parameters that it has and try to respond to that. Okay. And when it is responding to that, it would respond based on certain parameter known as the confidence. Okay. So it may happen that the LLM is extremely confident that the information that it is providing is accurate. But in reality, that may not be the case. Like the example of 4 + 5 is greater than 10 is hallucination, because if you're saying that, it is saying that, if it is 9 is greater than 10, that is hallucination, because we know as human beings that 9 is not greater than 10. So that's another aspect where hallucinations do happen because of either incorrect information being passed as input to the model, or the parameters that are being trained upon may not be able to give the exact information based on which it can answer accurately. Okay, so these three are the major components. Yes, there are other components as well, but these three are the driving force behind coming up with RAG. We'll see how RAG is going to address this. Okay, but before we came up with RAG, we came up with another solution. We came up with something called fine-tuning. What is fine-tuning? So I mentioned that IBM has its own policies, but that's not available on the internet, right? And what IBM can do is it can take the ChatGPT's model, or IBM has its own set of large language models, and bring that on board and pass in all the IBM specific data and pre-train that LLM on the IBM specific data, and then ask questions related to the IBM policies, and then that model would be able to answer that specific information. So if I were to give you a layman understanding, let's say somebody is trained, somebody speaks English as the language. Okay, somebody from Britain speaks English. Okay, if he comes over to India, on the very first day, he would not be able to either understand or speak Hindi, right? Let's say he spends 1 month with us, and by constant interaction with the people in India, that person would be able to understand some basic understanding of what Hindi is, what to respond, and how to understand Hindi, right? So fine tuning is nothing but taking a pre-trained model and training that again on a smaller domain specific data, so that it can also respond to the questions on which it was not previously trained upon. Okay, so by training the model on private data, what we are trying to address is the knowledge limitation. So earlier it was not trained on IBM specific policies. Now it is being trained. So Devansh has a question. Go ahead, Devansh. Devansh, go ahead.
Yeah, good evening, sir.
Good evening.
Like currently you raised the thing that we can, like for the LLM models which are present there, they have a limited data set, and there are some data set which are trained on private data, and there are some data set which have some mm, lack of knowledge, right?
Yes.
But what about the models which uses the whole internet? Like recently I used Gemini.
Mhm.
And Gemini has an option to search for the internet. Like if you know, Google introduced its AI mode right now, so
Yes.
that you can directly search in it.
Yes.
It goes through the whole internet, searches all the web pages, basically all the websites which are relevant to it, and then finds a basic solution to it. So how can you say that that particular model is not trained on private data also? Because Google in its database has a lot of data which is not available to the public user directly. You need to access it in a very different way, which I'm not sure about it, but it's known as docking. Google docking is a method which we used to do. That's a
Yeah.
term in cybersecurity.
Mhm.
So the thing is that generally when this kind of data is present and which is not accessible to the public very easily, then the LLM could access it very easily. So how can we say that the private data is not accessible by the LLMs?
Good question. So I'll give you two examples to drive home my point. When I say that it is not trained on private data, all the information about we were talking about the IBM leave policy, right? So IBM leave policy is not something that's available on the internet. It is available on IBM's intranet. Okay, there's a difference. Internet is where somebody wants to keep a domain that's available to everyone. Anybody can go out and access. But IBM's intranet is not something that's available to everyone to go out and access. You need to have certain authentication that needs to go in. Only then you would be able to access that particular information. So even though Gemini or even ChatGPT, they are trained on internet, they are not trained on individual companies' intranet, right? If I were to give you a very plain terminology, let's say that if I were to say that, I'm training a model on all the books available in the library, okay? Does that mean it is also trained on the notes that you yourself had made from those library books? No, right? If it is trained on library, that means it is trained only on all the books that were available within that library. All the personal notes that you have made for yourself and the keynotes that you've added for yourself, that would not be readily available in the model. It would only available from the library books that it has been trained on. There's a difference between private data and publicly available data. All the chatbots that are available today, the LLMs that are available today are generally trained on public data, and then they are fine-tuned by training them on private data by companies, whoever wants to add more data to those models. But in general, they're not trained on private data. Hope that answers your questions. Now, moving to the next part, the knowledge limitation gets slightly addressed with the fine-tuning approach, but overcoming hallucination by explicitly saying stick to facts works to some extent, but you can actually train the model to respond with things like, probably I don't know because I do not have that information available readily whenever the confidence levels are low, right? So even with fine tuning, there are still another 3 challenges that we face, all right? So the first one is with fine tuning, the overall process is computationally expensive. As we all know, that there are billions and billions of parameters for each model that is available. So some of the smallest models also have at least 70 million or 1 billion parameters, right? So when you try to train these models on your domain specific information, you would require high computational power, especially GPUs, to train that particular model. And generally, these are not done on your local machines. These are generally done in the cloud where you have the GPUs available for you. So that's number 1 requirement for you to fine tune your models. Number 2 is strong technical expertise. You cannot just bring some data and train it on the LLM. You need to also have some expertise of how the models operate, what parameters to tweak, or what changes needs to be performed before you can pre-train, before you can fine-tune a pre-trained model. So that has to be taken into account. And the last part is frequent updates. So this is more related to the knowledge cutoff part, because every time there is something new that's coming in, you would have to train that model again and again, right? So let's say you trained the model on the 1st of July, and after 1st of July, there were 3 major world events that took place. And if somebody comes in and asks questions related to that, if it is readily available on the internet, then the LLM might be able to pick it up. But if it is not readily available and it's more private data or some other changes that have happened that is not readily available, then you would have to bring that model and fine tune it based on the recent updates that have happened. And again, with frequent updates, it is a cycle where you again have to invest in a computationally expensive resources and also bring the technical expertise all the time. All right. So all in all, the fine tuning approach solves the problem to some extent, but it does not completely solve it, and also brings in new aspects that does not support the LLM on its own approach. Okay. So now we will talk about the RAG architecture that will try to solve this particular problem in 3 separate ways. Okay. So before I talk about RAG, what we are doing with RAG is, as the example that I gave, you call your friend, or let's say you're writing an exam, okay? Let's say you're writing an open book exam where you've learned some things that you are able to answer on your own. But what if I also provide you your textbook that is next to your desk and say, try to answer the questions on your own, but wherever you're not confident, open the book, look at the question, and then try to answer it from that textbook, all right? So that's more like an open book response where you have your own knowledge, and on top of that, you are also getting the knowledge from the textbook wherever you are not confident. Yes, Lilanshu, you have a question? Go ahead, Lilanshu.
Sir, please see the that I have question in the chat. I have the problem in the board.
Okay, confusion between AI agent or AI workflows are when we fine tune the data, doesn't the private data goes to LLM's company or private data? I heard not to give company code to the LLM ChatGPT for debug. Yes, Himanshu, Lilanshu, yes, there is that always that risk associated when you train an LLM. So when you train the LLM, you bring it on board into your own company's premises, into your own company's cloud, and then train it. So that information would not again go back to the companies. Because if that is the case, then all the companies would get every other company's private data. That is not the case. When you have to fine tune or pre-train, train another pre-trained model, you generally bring it into your own company's premises, where all of the information is controlled by that particular organization who has the private data, and based on that, it will be able to pre-train or change the parameters of that particular model. Right? Now, for the RAG architecture, this would be divided into 4 key segments. Okay, let's look at one of them one at a time. Okay, so the first thing is the user asks a question. I think everybody knows that for ChatGPT, you just open, you type in your question. Okay, whatever your question is, the user types a question. Okay, and then we have something called a smart retriever. Okay, and the purpose of this smart retriever is to take the user's question and then search based on that question in a vector database. We'll talk what vector database in a minute, but what it will do is it will take that particular question, break it down into a semantically understandable phrase, and send a query to the database, which is the database of private information or the private data which the LLM may or may not be already trained upon. Okay, and from that it will try to extract some relevant information that is related to the question asked by the user. Okay, now with that information that it has extracted from the database, what it will do is it will add that to the user question. So the relevant chunks or the information that it has got from the database plus the user question, it will add into a prompt template. So not earlier, the direct question used to go to the LLM, and the LLM used to, based on the training that it has been answered, it will be able to answer that question. But now there are 2 steps that have been added, where in the first step, the user question is converted into something called embeddings. And based on those embeddings, we perform the semantic search. Semantic search is nothing but getting the underlying meaning of that question, and based on that, searching in the database, and based on that, extracting the relevant chunks of information that can be associated with the user's question, and then combining the user's question plus the context that we got from the relevant chunks, we pass that in the form of a prompt template to the LLM. Now, LLM not only has the question, but it also has some relevant chunks of information that will give it the context and confidence based on which it would now be able to answer questions. Number one, it would be able to answer questions on which it was not earlier trained upon. And number two, it would also be able to answer questions with higher confidence, thereby overcoming the hallucination part. Okay, so what happens is, this area that you see, the corpus of text plus the vector store, I think this is where the RAG approach happens. Okay, so it happens in 4 different stages. So number one is indexing. Okay, so again, coming back to the IBM policy. So if you have IBM policy, what you would do is, firstly, you would have that in your intranet, IBM's intranet. So firstly, what you would do is you would do some web crawling to fetch that data, do some text processing, ingest the data into the database, perform the embeddings and chunking, and store the documents. Okay, so here you see that chunks, index, and embedding, all of that combined is known as the text processing. So the web crawling that happens on the IBM intranet, all of that information gets stored into a vector store. So now, what is a vector store? We all know that we have databases which stores information in rows and columns, right? But for LLMs, the information required is in the form of numbers, right? So each word, each question that gets asked is firstly broken down into tokens, or you can call them as individual words. And each individual word is represented as a vector. A vector is nothing but a numerical representation of word in the vector space. Okay, so for example, if king is 52, queen would be 50. Okay, in the vector space, that would be the number assigned, for example. So now if somebody asks a question, the king of America, for example, is ABC. So then that would mean that it would take 52 as a representation for the term king and stores that in the vector store. Okay, and whenever it asks a question of, I have embedding number 52 in my question, that would mean that it will fetch information related to the king and pass it as relevant chunks to the smart retriever. Okay. Now, once the information is passed back in the form of semantic search as relevant chunks, that's where we call the retrieval, where we find the relevant information. As I mentioned, you would have the information in the form of query embedding, and then based on that, you perform the semantic search. And once the semantic search results are returned, it would rank those results based on the confidence and fetch the chunks of information that has the highest rank. Okay, and then the augmentation part is where the prompt creation happens. Earlier, the prompt was direct question to the LLM query. Now the prompt creation would be the smart retriever retrieved relevant chunks plus the user question in the form of embeddings is passed to the LLM query. That way, you are augmenting the prompt creation by adding more context and more relevant chunks of information to that question, so that LLM has all the information that it needs to be able to respond with high level of confidence. And at the end, the retrieval part is where the formulate answer takes place, where the LLM uses the augmented prompt for higher accuracy and lower hallucination and be able to respond to the questions which it has not already been trained upon. All right, so that's the RAG architecture. Simple thing. Number one is the user question. Number two is the smart retriever, where it gets the information in the form of chunks and embedding from the vector store. And that relevant chunks is added to the user question and in the form of a prompt template that is then passed into the LLM. Now LLM has more context and more information pertaining to the user question. And based on that, it is able to answer with high level of confidence. All right. So that's the RAG architecture. Now let's take a look at the issues or the challenges that we had before. Number one, private data. Okay. Earlier, we did not have one second. Okay, earlier the LLM was missing this vector store or the corpus of text part, right? This is the private data that we are talking about. So now companies can upload their private data in the form of vector store, and the smart retriever can just connect to the vector store and fetch the information. And we don't have to train the LLM every time there is some update that's happening in the vector store. Okay, so that's the private data. Because we now have a knowledge base that's not part of the LLM itself, it can just, you can keep on updating the knowledge base every time there is an update, and LLM operations are not impacted. Number two is knowledge cutoff. As we discussed, any event that keeps on happening, earlier what we had to do was we had to train the LLM once again. Now that is not required. You can just update your knowledge base in the background, and with the smart retriever, LLM can get that context through smart retriever and still be able to answer questions that may be occurring even after the knowledge cutoff date. The third part, hallucinations, as we discussed, now because it has more context, it would be able to give you more grounded responses, which are more accurate than when it was able to respond on its own based on the information that it had. The fourth important aspect is the cost and simplifications. With fine-tuning approach, we have seen that every time we have to retrain a model, we had to bring in the computationally expensive resources like GPUs. Now, with the RAG approach, You just bring in the knowledge base in the form of vector database, update that vector database with the knowledge every time there is a change, and you would be able to address all of that on the fly. Now, moving to the next part, the evolution part. Okay, so how did the overall evolution of RAG happen? So the first architecture for RAG was released by Facebook AI in the year 2020. Okay, and then in 2021, the academic interest in open domain for question answering was seen rising, and RAG interest was growing at that particular time. In 2022, for the first time, Facebook AI's semantic search and Elasticsearch started integrating the RAG approach in their tools. And then by 2023, we have LangChain and Pinecone popularize the low-code RAG pipelines that would help people to update the LLMs with the database information that is readily available. And today, in 2024, we already have the emergence of multimodal RAG, where not just the text part, but you can also have the database or the vector stores for images and video as well. And that would be the multimodal part, where instead of just text, you would be able to play with images and video part as well. All right, now some of the RAG applications. All right, so this is important to understand where RAG is being used. So today for education part, there are custom syllabuses that are being prepared by autonomous organizations, where they would like to have their own set of syllabus along with what LLMs are already being trained upon. So that's where the education system is making use of it. The customer support, all right? So the product specific information is not again readily available, right? Or the LLMs are trained on that, or any new product that's coming out. So all of that product specific information, the chatbots would not be able to answer. And I think that is where, through the RAG approach, the LLMs would be able to refer to the RAG and provide product specific information on which they are not already trained on. The legal research, the healthcare domain, and the enterprise, like the IBM example that I just gave, all of these areas are actively implementing the RAG approach to be able to use LLMs for their day-to-day activities. Now, these are some of the resources that I just want to put out there. Number one is IBM has its own data prep kit that it has prepared that would make things easier for you to build your own vector database, as well as pre-train or update your LLMs based on the vector store that you have. So I think this would be one good repository that you'd like to just go out and explore on your own. And then also SkillsBuild has some of the resources that are available in the form of courses for you to be able to use Unleashing the Power of Agents or the Rise of Multi-Agent System. I think these are some of the courses that you can start utilizing to gain more insightful information about RAG and agentic AI. I'll pause here to take a couple of questions, and then we'll move to the demo part. Yes, Akash, you have a question. Go ahead, Akash.
Sir, I am Akash. I have a question, that is, what is semantic search in RAG?
Semantic search. Semantic search.
What is the role of semantic search in that?
Yes. Semantic search is nothing but, if I were to put it in layman's terminology, if you are asking, get me 6 pens, all right? 6 is a number, pens is an object, all of that broken down into a form where semantically it would make some sense to the LLM. I think that's where the semantic search would come into picture. How do I put this? Semantic is more like, the grammatical information part, where semantics would mean to breaking things down into individual words and then taking the context out of individual words and then trying to respond to that. So for example, I'll give you a simple example of semantic search. If I were to say, go to the bank and withdraw money, okay, that's one phrase. Then there is another phase, go to the bank and fetch some water. Okay, so in the first case, go to the bank would mean going to the financial institution called bank and withdraw money, right? If I just say go to the bank, you would be confused whether you have to go to the financial institution or if you have to go to the river bank where the river flows and fetch the water. So without the semantic breakdown, if I just say go to the bank, the LLM would be confused whether you're referring to the financial institution or whether you're referring to the river bank, right? So that's the semantic information where you're actually breaking down the words and providing the actual meaning behind those words. I think that's what semantic search means. Any other questions? Can you please? Krishna, FAISS, Elasticsearch are some of the, FAISS is Facebook AI's semantic search tool that is used for searching things. Elasticsearch is also more or less fetching information. It's a tool again that is used to extract information from databases. And Elasticsearch is known for fetching the information or querying the data in a very rapid form. Pinecone is one of the vector database providers where they would be able to store the information in the form of embeddings instead of rows and columns. As we all know that databases store information as rows and columns, right? Whereas vector databases stores information in the form of embeddings, which are nothing but the vector representation or the numeric representation of individual words. All right. Now, let's quickly jump over to the demo part where we would see a RAG implementation. All right. So at the end of the session, I had mentioned that IBM has its own data prep kit, which is a repository that's available for public to be able to play around with the RAG functionality. Okay. What this means is they have cleared out some of the data preparation steps that are necessary for you to create your own vector database and then also create a RAG on the fly so that you can pass in certain information that LLMs are not already trained on and then see how the outputs come out. Okay. So the first thing you would have to do is go to the RAG HTML part. So under examples, you have RAG HTML1. Okay. And within that, firstly, open up the myconfig file. Okay. And the myconfig file has some of the information. I think this is something that you can play around with. What we are trying to do is we have a website called thealliance.ai. Okay. And we would first try to get the information that's available on this website. Okay. Bring that information in the form of data frame and convert that data frame into a markdown file. And then we will store that markdown file into a vector database known as Milvus. Milvus is a vector database that's provided by IBM for creating the vector stores. Okay, so the information that you need to be providing is which is the website that you would like to crawl, and this information would remain the same. The embedding model is nothing but the model takes the overall corpus of data. Corpus of data is nothing but the entire words that are part of your data set. It will take that and it would convert it into the form of NumPy arrays. Simply put, NumPy arrays. Okay, it would be represented in the form of numbers, but anybody who knows Python, they know that NumPy arrays is how the embeddings are created. And the embedding length, you would be specifying 384, but you can play around with this. The chunk size is 512 in this example. Chunk size is nothing but how many embeddings that it would be able to take in each chunk. Chunk is nothing but if you have, let's say, 10 rows of data, and if I say my chunk size is, let's say, 5 rows, that means you will have 2 chunks, one of 5 rows and another one of 5 rows. That's how it would work. Now, this is important, myconfig.db URI. I think this is the URI where your database gets created for your embeddings. And for collection, I think this is all about the embeddings that get stored in the form of a name. That's the collection name. And the LLM model that we would be using is Meta's Llama 8 billion instruct model, but you're free to explore with other models as well. Okay, so that's the config file. In the .env file, you would have to store the key that would be required. I'll show you when we get to that part. There would be a key that you would have to pass in based on which the model would function for you. Okay, so the first part is, crawling the site. I think we all have been through this, where crawling is nothing but you connect to a particular website and fetch the information from that particular website. That's what crawling is. Okay, these three are part of Python's inbuilt libraries, and this is the data prep kit's web2parquet transform function. So this function, what it does is it will connect to the website that you're talking about and fetch the information and provide us that details. Okay, so here we are doing the directory setup. So let me run this. So here we'll run the directory. Right now, if I would want to show you, you would see that, there are certain HTML files that are already available. So now I would want to clear that out first. Okay, so clear the download directory. Now, if I go back to the input directory, you would see that these are blank. Okay. Now, the next step is crawling the website. For this, we use something called the DPK connector, which is a utility to download HTML pages from a site that's already pre-built into this data prep kit. Okay, so the website that we're using is, you pass in the list of URLs, the alliance.ai or any other websites. Okay, and now you come in and say web2parquet is the function that's defined in the data prep kit. You just run this part, and now you would see that it is connecting and it is fetching the information from these websites. So within alliance.ai, it is going to the various parts. So within alliance.ai, it is going under focus areas, and under focus areas, it is fetching the skills education information. And each of that, it is creating in the form of a HTML file. Okay, now to confirm that, let's go to the input section. And you would see that it has created 20 HTML files for us, as that will act as input for our vector database. For now, we've just connected to a website. We've fetched the information from that particular website. Okay, and this is just a confirmation that we've completed the web crawl. We have 20 files downloaded into input directory. All right, so that's the first part. Now, going to the next part, this is where you do the configuration. Okay, just do the basic runs. That would get you the files. And now I'm clearing the output directory. So earlier the output directory had the HTML files. Now both of them are empty, because now what we would be doing is we will be taking the HTML files that we have as in the input folder, and we will bring the information from the HTML file into the HTML to Parquet format. So now it will say result is equals to HTML to Parquet. Again, this is one of the functions that is defined here. From dpk html parquet.transform, HTML to Parquet is the function that we have that's defined in that particular module. So we bring that in and we would just run that, and you would see that it is now creating the files for us. Okay. Now operation completed. now what we would do is we will create a data frame out of these Parquet files. Okay, so now we have 20 Parquet files, total 20 rows. So now you can see that the title, document contents, and document ID size are the columns. And you would see that the first HTML that we had was for the alliance_AI. Okay, and these are the contents. The contents column will consist of all the information that's available on this particular page, and it will have its own document ID. So now let's take a look at some of the examples. So now if I were to just look at the first title in my data frame, that's the Alliance AI. If I were to look at the document, that's this one. And now let's print the contents of the first row. Okay, so here you can see that the open source AI community and the entire information that's available on that page is available in the form of raw text. Okay, so now what we would do is we will take that information and store in the form of markdown file that we would be able to store in the form of a vector database. So let me run this. Now we have 20 markdown files saved in the output/2 markdown. Okay, so here, if we go back to output folder, you would see that 2 markdown has all of these .md files that we just created. So until now, what we've done is we've connected to a website, done web crawling on that particular website, brought in the HTML files as the output, again converted those HTML files into the Parquet format, and from that Parquet format we were able to generate a data frame, and using that data frame we have created the markdown files, and we'll see how we would use these markdown files in the third one. So now vector database. Again, vector database, as we discussed, is a database that stores the embeddings or the vectors in the form of numbers. Numerical representation of words is known as vectors. Okay, so we use the llama index that helps us in connecting the LLMs to the external sources, in this case the vector database. Okay, so we import all of that and we define the markdown patterns. Let me run this again. Okay, and simple directory reader is one of the classes that's available in llama index. So you just run those. And now if I were to just print the first document, again, you can see that this is the same text that was available in the HTML and markdown files. Okay, so now what we do is we first break this information into chunks. Chunks is nothing but you have, let's say, 100 lines of code, you convert it into 25 lines of each chunk. So then you would have 4 chunks of information that would be easy to process. Okay, so in this row we would do the chunking part, and then now we start creating the embedding model. Embedding model, as I mentioned, embedding model takes the sentences or words and converts them in the form of embeddings, also known as vectors. Okay, so first let's download the model. Okay, so for the embedding part, we would be using the Granite embedding 30 million English model. Okay, and now let's configure that. Okay, and now Milvus. Milvus is a vector database that's provided by IBM, and it will store the embedding information that you have just extracted from this particular document IDs. So each document ID will have information in the form of embeddings, in the form of chunks firstly, and those chunks are then getting converted into embeddings, and those embeddings will be stored into the Milvus database. So let's connect to the Milvus database and create the vector store. Okay, so now it says connected to llama index to the Milvus instance. So this rag html.db, you can see here that it has been created. Now this will act as the Milvus instance for us to store the information. Okay, you would have to create an index that will fetch the information from the database. Okay, so now we can see that 55 chunks of information is now stored in the Milvus collection. The collection name is nothing but docs, as we have specified in the myconfig file. Here we have specified that my collection name should be docs. So that is what it is saying. Okay, so now again repeating myself. Firstly, we did the crawling of site, fetch the information in the form of HTML files, converted the HTML files into Parquet files and then into a data frame. From the data frame, we generated markdown files, which has all the website information, converted that information into embeddings and chunks, and stored that information into the Milvus database that will act as the RAG component. The database is going to store the vector information for all the database, all the data that we have crawled from the websites. Okay, so the last part, I think this is where the RAG on HTML documents is going to work like. So this is where everything comes into action. So let's run this part. We import all of the necessary components, the embeddings part. I think we did this in the previous instance, so but let's just rerun this to make sure that we are getting the embeddings and everything right for ourselves. And this is the vector store, which has the DBURI is nothing but the rag_html.db. The embedding length was 512. The collection name is docs that we've already specified. Okay. Okay, so now it is connected to the Milvus instance, the instance that we have defined here. And this instance has all the information about alliance.ai, right? So this is more like a textbook, which is specific to alliance.ai. So any questions that the LLM, the Llama index is not, the Llama model is not able to answer, it will connect to this particular RAG HTML database and try to answer those. Okay, so let's take a look at that. So first, let's define our vector index. And from the .env, we would import the configuration details. And let's do the printing. And here, now you first set up the query engine, okay? And then you will ask the questions through the query engine by passing in your questions. So here what I'm saying is, what is AI Alliance? Okay, just a simple question. What is AI Alliance? The LLM might be pre-trained on this, or sometimes if it is private data, LLM would not have any information about AI Alliance, right? But now that we have set up the RAG HTML component here, the LLM would also be contacting RAG HTML in the background, and based on the information that it retrieves, it would be able to answer that question. So now if I say query engine, vector index, it would say what is AI Alliance? It will try to respond to that. Okay, so now you can see based on the provided context information, the AI Alliance is an organization that aims to provide, so it will provide you the entire information that's available in the embedding form in the vector database. Same thing, let's do, where was the demo night held? Okay, so in this case, the AI Alliance had a demo night that they had conducted, and we are just asking where was that demo night held for them. So it would go through the entire vector database, and it says according to the context information. Again, remember that the context here is the demo night can be of anything, right? But here it is getting the context that says, I'm talking about the demo night that was held by Alliance AI. So that is the context that it would get. Okay, and based on that, it says, according to the context information, the open source AI demo night. So look at the double quotes. This means that, it is able to connect to your vector store and get the information based on the confidence level, and then respond by saying the open source AI demo night was held at Shack 15 in San Francisco. Exactly information coming out of your vector database here, because this was the information that we had crawled from the Alliance AI's website. Now, this is important. So the vector index is nothing but the vector part of your RAG component, okay? And we know that the moon landing was something that was coming out of the LLM and not part of the vector. So here, if I ask when was the moon landing done, it would say that it would not have that information, because the information that we have crawled from Alliance AI would not have that information. So it says, I'm happy to help. However, I do not see any information about moon landing in the provided context. So the context here is nothing but the RAG HTML database. And if that information is not available, it will just come back and say that I do not know, instead of hallucinating and saying that, the moon landing may have happened on ABC date. That's the advantage here. Okay. So that's more or less the implementation of the RAG component using the Milvus vector database, right? I'll pause here and take any questions that the participants may have. Any questions, guys? Yeah, Ritika, you have a question?
Sir, can you tell me working once again?
Sorry, tell me.
Working once again of this.
Sorry, I didn't get your question. What's your question?
Basically, you write the code and explain that once again. You can tell me in short way.
Akash, what I would recommend is I'll share the deck after the call, and it has the GitHub repository. Ideally, I would recommend that you take that repository and try to run the code on your machine. That would give you more insight. Because I can demo it once again, but again, the code is going to be the same. So there's not going to be much insight for you on that. Take the repository and run it on your local machine. I think that's where you would get more information. Mayank, what is the prerequisite to learn the RAG technology? Python would be the first prerequisite. Vector databases, I think you need to have a good understanding of vector databases. The NLP, natural language processing, would also be a prerequisite. And then LLMs. I think these four would be the key terminologies or key components that you would have to know before you can implement RAG technology.
Sir?
Yes. Go ahead.
So like whatever codes you have written, you have written in Visual Studio, right?
Yes.
So all the codes we also have to run, and we also want to see the output. So how we can get all that things codes from you?
So after the session, the deck that I was presenting, I will share that with the hosts, the CSR box team. They will share those resources, and you will see a GitHub link in there. Okay, so you just take that GitHub link and either fork it or clone it on your local machine, and you would have to provide the API key for connecting to that. I think if you just provide that API, you would be able to register that for free, the API key. And once you provide that, I think you would be able to run it on your local machine. You don't have to write that code once again.
Okay, so yeah.
Right. What is the significance of RAG? I think the significance I just demonstrated. Because you have those limitations of knowledge cutoff or private data or hallucination, I think that those components are being addressed through RAG, where you are also able to train on private data on your own premises and make use of the LLM functionality on your own private data.
Sir, I have another question. That is how work LLM transform architecture.
How LLM?
Transformer architecture.
How LLM? I don't get your question. So are you asking what is a transformer architecture?
Yes, sir.
Akash, I think that's beyond the scope of this presentation, because transformer architecture would take another 1 or 2 hours to go through that entire thing. I would recommend that you can watch some YouTube videos, especially from CampusX. Nitish Singh has a very good explanation of what a transformer architecture looks like and how it's implemented. It's more or less a deep learning model which has both the encoder and decoder functionality. So go through that, and Google has its own paper on transformer. So going through both of those, I think you would get hands-on information. Currently, I'm working on agriculture rate process. I was thinking of implementing a rack system to answer query from us. So I can do using a document or a site that has information. Yes. So Manish, you can create your information either in the form of Word documents or Markdown files. And using those Markdown files, store that information in the form of embeddings in a vector database. And then using that as your augmentation capability, you would be able to interact with LLMs and respond to the farmers' questions based on the information that you provide.
Hello, sir.
Yes.
May I know that can RAG work well with a small or limited data?
Yes. So remember that RAG is nothing but looking up information in the database. If it is available, it will respond with that. If it is not available, it will come back. Like the example that I just showed, when was the moon landing done? It did not have the information, so it will just come back and say it is not available. Instead, the LLMs might try to see which is the most closest information to that and try to get your response. RAG doesn't do that. RAG just goes and looks for the semantically similar information. If it is available in your RAG, in your database, it will just fetch that information. And if it is missing, it will just come back and say it is not available. So the amount of information is not important there. I think the questions, based on that question, if that information is available, it will be brought back. If it is not, then it will just say it is not available.
Okay, sir. Thank you.
Welcome.
Hello, sir.
Hi. Hi,
It's
Rishikesh.
Rishikesh here. I just want to ask a question with respect to building up an multi-agenting system with RAG. So my question,
Yes.
multi-agentic system with RAG.
Yes.
So my question is, if I want to build a system from scratch for an say entirely new organization,
Okay.
and with respect to that, I have a very limited context to consider as a for a rack system.
Okay.
If I gone for a search to the respective context, if it doesn't finds me through various resources, then how can we approach for to build up multi-agentic system? If it finds me, then how can I use it precisely with respect to my objective for the system? To be precise, if I want to build a multi-agentic system totally human free for a startup, say that.
Mhm.
So how would I process that, or should I take the steps to approach it?
So for building a multi-agent system, RAG would be one of the components, because you would have to provide it the context for the agents to get triggered and everything. So if you have limited context, I think you would first have to start building on that context of what information is going to be looked at and is that readily available. And if it is not, then how can you start building your vector database with the RAG information and then connect your agents to the RAG to be able to fetch that information for you.
But it will be feasible, no, sir? Means it is possible.
Yeah, absolutely.
Okay, sir. Okay. Thank you, sir. Thank you.
Sure. Will we have a drive link of this session? Can somebody from CSR team answer? Do we have drive link of this session or all the materials?
Yes, Mr.
Hi,
Abdul,
Sundar.
they
Yes, we
will
are
receive
sharing.
all of that.
Okay, thank you. Abdul Kareem, sir, what if I want to use my own data like image, doc, PDF for RAG? How can I do that? So again, as I mentioned, you can start using something called the markdown file. If you go through this repository, you would see that how can you bring completely new data, convert it into embeddings, and then store it into a separate vector database. You can use any of the open source vector databases as well. And then you can connect that to your LLMs so that, you know, they would be able to gain context from that vector database and respond to your questions.
Sir, may I ask?
Yes, Karthik.
So, sir, we cannot connect like any website to this RAG architecture, right? Like,
You can. So the Alliance AI that I just demonstrated, I think that's just a website that's available on the public domain, right? So you can connect to that. But then certain websites can have limitations with crawling. So you just have to be aware of that. But otherwise, any website that allows you to crawl the data from their website, you should be able to fetch the data and convert it into a vector database.
okay, sir. So in order to do that, we just like change the address in the configuration file, right?
Correct.
Okay.
Yes, take the configuration file. You need to specify which website do you want to crawl and see, and then run through the code that's available in the examples folder.
Okay, sir.
Yes, somebody had another question.
So I want to ask that in LLM, whenever we put a prompt, it's mostly incorrect or grammatically incorrect since it gets it right. And what's the work of RAG over here?
Even if you type grammatically or spelling mistakes are there in your question, it will be able to give you the right answer. The simple answer to that is because LLMs do not look at the exact thing. They would look at the underlying semantic search that we just discussed. It will convert all of your textual information into an embedding or the vector format. And then based on that, it would look up in its own database. The work of RAG in this case is the information that LLM may not have. It is augmenting that information by providing it through a separate database. LLM interacts with that database and be able to answer the questions based on which it was either not confident or it had no information about. It is now able to answer by fetching that information from the RAG database.
So it means it will use a huge database or it wanted a large amount of data for it?
Not necessarily large, Rituparna. I think all we are saying is, so for example, you're writing your exam, okay? You have 2 marks question that you want to write. You just look at your textbook, go to that specific chapter and look at the answer and come back and write your 2 marks question, right? It does not matter how much information it has to look at in the database. All that it cares about is the semantic search it is providing. Is that semantic search retrieving any results? Yes or no? If it is retrieving the results, then it will just show that information to the user. If the semantic search is not returning any results from the database, then it will just come back and say that that information is not available even in the vector database.
Yes, sir. Thank you.
Sir, I have two questions. So the first question which I want to ask is, like you mentioned that generally when we work on RAG, we used to have a private data set. Like we have a vector data set which is limited to a company or an
Correct.
organization, right?
Yes.
What if, like, if I take an example for this, I have a medical firm, right? I have an hospital or a hospital chain consuming, and there are people, there are doctors practicing also, right?
Yes.
So I have a agent which is based on RAG also. Now I want it to be general also. Matlab, it has my hospital data also, but
Yes.
I want to have a general perspective also, like which is of ChatGPT and Gemini models. They have that general perspective.
Yes.
So is there a way to protect my private data from the exposure so that the particular thing which I want to establish in the generalism and that the private data is protected and it is not affected by the public use, like it is not exposed to the public use?
Got your question. So firstly, if you want to so you need to have 2 separate instances. The instance where you are making use of the RAG, and the moment you start using RAG, that would mean that your data would become, especially the use of RAG would be used when you have the users that belong to the same organization or the same group whom would have the access to the private data. But the moment you expose it to the general public, then there is no guarantee that the information fetched from your RAG database would still remain private, because once you expose it to the general public, it would become available to everyone outside, and they would be able to ask those questions related to your private data, and they would still be able to get the answer. The LLM would not stop or limit that. You as the designer of that particular application, you would have to design it in such a way that uh, if the access point is outside your organization, then you keep it limited to the LLM's knowledge. And if somebody from an internal organization is trying to access that information, then you can make use of the RAG, something like that.
Got it. So, like, if we talk about in terms of ChatGPT, it also behaves as a RAG at times. Like, yeah, I don't have a very large data set, but yeah, I used to work with ChatGPT in my day-to-day life. I
Yeah.
have a lot of code files where I get stuck on it. So I just used to upload it on that chat window, and then it gives me the result, whatever I need to process it by giving the prompt. So I think that is also a part of a RAG, I guess.
No, that is not
That's
part
not a
of
part
the
of a RAG.
because that is LLM getting trained itself. So that is not RAG. RAG is when you do not touch the LLM's knowledge. The LLM's knowledge remains as is. And to answer certain questions which are not part of the current knowledge of LLM, it will connect to the RAG component, the database, the vector database, and gets that knowledge. That is the RAG component. You as an end user, if you are giving more information to the LLM, that is LLM learning with experience, right? That is not RAG.
So wouldn't it be a context rather than learning, because
It would
I'm
be
giving
context.
it just
Yes,
a
yes. It would be context
So
where you provide more information. But RAG is not just about context. RAG is about augmenting the information so that if that information is not readily available in the LLM, then use this information with confidence and respond to that.
Okay. Answer my next question says, like, you mentioned that we used crawling for
Yes.
taking out the contents of the website. There is also another method which is called scraping.
Yes.
So are there any differences between scraping and crawling, or they are identical?
Well, there might be minute differences, but eventually scraping also gets you the information from the website. It's just that there are various other libraries that are available. So for scraping, you would use something called Beautiful Soup that would fetch the information from there.
Beautiful Soup and Selenium.
Correct, Selenium kind of things. But in terms of crawling, this is we called it crawling because crawling is more like a technical term. And we have this particular data prep kit that use the crawling as a methodology. But I wouldn't say there would be a lot of differences between crawling and this thing, scraping.
Okay. Thanks a lot. That's all.
Sure.
Hello.
Yes.
Yeah, sir, my question is that we have some AI technologies nowadays like Gemini and Perplexity, which uses RAG to either crawl websites to get the info that we want from it. And what if there is a website and it has some malicious, text like a prompt injection or something like that, and they try to use it for their own AdSense, or like for like we asked it a code, and rather than going to some Geek for Geeks, it went to some other website, and there some malicious code is provided through the LLM to us. Like how these companies handle that, these big giants.
Right. It's all about training with accurate information, Rudra, because for LLMs or even for machine learning models, garbage in, garbage out, that is the functionality, right? They do not have that functionality to train themselves on their own. Agentic AI is something that's evolving now, but you have to be careful of what data you're training the large language model on, right? And then when you're providing the RAG information or the RAG context, you have to make sure that your database is also protected so that it is not infected and provide incorrect information to the LLM based on which it will respond.
Okay. Thank you.
Sir?
Yes.
There is one doubt in machine learning. It's not about RAG or anything. So I came across this problem that I have a data set of healthcare data set, which is a classification problem.
Okay.
And the variables are like smoking status and cholesterol, likewise.
Okay.
Now, there is no correlation between the variables, and I am getting the metrics as low as uh, 0.50 or 50% accuracy I am getting. So, what is the suggestion you could give to me?
Well, I can give you generic suggestions. First and foremost is check if you have uh, any data cleaning activity that is required, number one. Number two is perform some data transformations to check collinearity, and then see if there are any patterns in your data based on which you can predict what you're trying to predict. But I think
Yeah.
we'll only say if after taking a look at the data sets, I mean, just through the,
So,
yes.
here I have seen correlation between the variables, between the target variable and other variables. I got the correlation as 0.0001 as highest correlation, and others are going into negatives. It's the data set fault, right?
Yeah, I mean, so again, only if there is something that can predict your target variable, only then you would be able to build a machine learning model. But if those things are not predictable at all, right, the machine learning also can only perform to a certain extent, nothing beyond that. There's no magic that happens in the background just because you're trying to predict ABC with 10 variables, and those 10 variables are not at all related to this one. It won't work, right?
Yes, but now if this problem occurs in the real world, like in the industry right now, how would you approach this one?
Correct. As I said, I would investigate further with the data set, try to plot certain things, understand how the data is coming out. And if it turns out that there is no relation between the target and the feature variables, then you just don't build the model. Simple.
Okay, sir.
Hello,
Okay,
sir.
so thank you very much. Oh, we have one more question. Okay, go ahead, Nadella.
Hello, sir. How is RAG different from the regular AI model like ChatGPT, Gemini?
So RAG is only a component that's part of the overall AI framework. The AI, the ChatGPTs, the ChatGPT or the Geminis that we're talking about, those are trained models, and the RAG component is helping those trained people with the information that they do not have knowledge as of now and respond with confidence. So
Okay, sir.
they're not the same. They are, RAG is one of the components that would enable the LLMs to respond to the questions that they do not have knowledge or have not high confidence on those components.
Okay, sir.
All right.
That can you please look
Yes.
at the chat?
Sir, I have a question.
Yes.
Sir, if we use and Google web pages for as a component for RAG, scraping the Google web pages, then would it work same as the Chat GPT scraping the web pages?
So ChatGPT is not doing the scraping here. We have a separate component that does the web crawling or web scraping.
Sir, I want to know that would it work if we scrape the Google
Google
for
is a
information?
search. Google is a search engine. Google is not a website.
Yes, sir. Let's say we use the search parameters and scrape the pages that result in that produces the result. And let's say we scrape at least 5 or 10 pages with top results, and
Okay.
would it and we use that information to provide the data for us to produce the relevant results.
Yes.
Would it work?
Yes. Yes. But again, you would have to scrape or crawl through those individual top 10 results that you've identified and fetch the data from those 10 results and then build your vector database. So Lilanshu, your question about agentic AI different from AI workflow, I think these are two separate systems. Agentic AI, I think it's an independent decision-making framework where you have agents that can take decisions on their own. Whereas workflow is more or less like the, 1 second, Sophia, I'll just respond to this and get back to you. Whereas agentic workflow is more of a process where multiple agents interact with each other to make that decision process. The overall agentic AI does. So in agentic AI, it's the overall system, whereas agentic workflow is the smaller components where individual agents interact to complete a certain task. Yes, Sophia, go ahead.
Sir, can RAG work with real-time or dynamic data sources?
Yes, as long as your database keeps on getting updated. So whatever the dynamic information that you're talking about, if that dynamic information is being processed into your vector database on the fly, it can work. So Shazia, you have a question. Can we use different programming languages for writing the code? I think with most of the open source today, Python is mostly the preferred language. R used to be the one that was in contention some time back, but based on the codes that I see in the open source environment today, I think Python is the most preferred one. Right. So how to reduce time complexity for RAG as we saw when the query was asked within the context of a query model. Yeah, so the query retrieval time, that would be dependent on the index that you have for your vector database. And the larger the database, the larger amount of time it would take. And the only way to improvise that is to add more indexing to it or add more processing power. Yes. All right. Karthik, I think that's more or less what we can answer for today.
Okay.
Over to you.
Thank you very much, Mr. Abdul. So, Mr. Abdul, before we leave, we have one last request to you as well as all the students. If you can all switch on your camera, we'll just take a screenshot, take a photo, just as a remembrance for this day. I would request Anil to please take a photo of all of us.
Right, done.
Yeah, yes. Thank you very much, Mr. Abdul.
Thanks, everyone. Have a good night. Bye.
All right, students. So I hope you all had a great experience. So about domain IDs, I know many of you are waiting for the domain IDs, but also we have dispatched many domain IDs till now. And a lot of you, primarily the team leaders, must have received their domain IDs, and maybe some other people as well, as we are sending them. But don't worry about that, people who have not received their domain IDs yet. we are dispatching them batch by batch, since a large amount can lead to the crashing of the website, or we are just don't want any issues to occur. Also, the process of registering on IBM Cloud is will the video link to the video that has the process for registration. It is also shared along with the same mail that contains a domain ID and password. All right, I'm sure you guys do not have any queries up until now. Devansh got the ID. All right. Okay, Naveen, we'll look into that issue. Farhan says, okay. All right. So thank you all very much for attending the session. You can mark your attendance. And thank you all very much. I'll see you for the next masterclass.